If you're going to slap a shot past the goalie in ice hockey, you need a stick that's strong enough to flex without snapping. Because the more flex, the more power and speed behind the shot. Wood used to be the standard for flexible strength. But now, composite sticks like this one dominate the game for pros and amateur players alike. Ice hockey sticks are made in two parts, the shaft and the blade. And the most popular material among players for the strong, solid shaft is this, a flexible material called carbon fiber. Carbon fiber is sort of like fabric, except it's woven together with super strong strands of carbon. These run through it like microscopic threads in a single direction, and the strands are held together by a plastic resin that's also in the fabric. The result is a material that's incredibly strong, lightweight and flexible. Everything an ice hockey stick needs to be. To turn this amazing fabric into the shaft of a stick, it's cut into pieces with a slight angle in the cut. Then two pieces are layered together face to face so that the carbon strands cross each other in opposite directions. A warm iron, just like the one you use at home, melts the plastic in the fabric to tack the two sheets together. Then, to vary the direction of the carbon strands even more, the pieces are joined along the angled cuts, so the seams can also be tacked together with the iron. All of this layering and seaming allows the strands of carbon to run parallel to each other in some parts of the fabric, which makes the stick stronger. They also intersect each other in other parts, and this makes the stick more flexible. The long sheets of carbon fiber squeeze through a hot roller. This permanently fuses the seams and the layers into one composite fabric. After the layers cool, the composite is cut to the right length for the shaft. And because of all the layers and the seams in the composite, each strip comes out with the carbon strands running in different directions. A worker wraps the long strips of composite around a mold, which mixes up the carbon strands even more to make a lightweight shaft with a hollow center. 20 strips are layered onto each shaft. If there is just one wrinkle or air bubble between the layers, it could compromise the shaft and cause the stick to snap. So to fuse all the layers together into one nearly unbreakable shaft, workers place the shafts inside compression tubes that are heated inside an oven at 148 degrees Celsius. As the shafts heat up, a rubber bladder inside each tube inflates around the shaft to put even more pressure on the layers while they're melted together. Once the shafts cool, they come off the molds and they are left with a hollow center. A special machine tests the flexibility of the finished shafts to be sure they can take the pressure of a player bearing down to shoot without snapping. The greater the flex, the more torque you can get into your shot, which increases the speed of the puck. While the shafts are tested, the outer surfaces of the blades are cut out of the same strong carbon fiber as the shafts. The strength of the carbon fiber is needed to protect the blade's inner core, which is made up of a small bladder between two pieces of foam. The soft foam cushions the impact of a puck hitting the blade. And it also increases the speed when the player shoots the puck back. But it takes 35 layers of carbon fiber around the core to make the blade strong enough to take the impact of all those pucks. To bind all the layers together, the blades are squeezed inside heated molds that squash them down with 8 tons of pressure. At the same time, the bladder inside the blade fills with air, compressing the sheets of carbon fiber from the inside out. This makes the blades even stronger. When the blades come out of the molds, they're ready to be attached to the shafts with super strong glue. Then, to be sure the finished products are up to Major League standards, random sticks get tested in a slap shot machine. The stick has to shoot at least 200 pucks at 120 kilometers per hour without snapping, or the whole batch is thrown out. If the sticks pass, the batch moves on to painting. Several different layers of color can go on, depending on the design. Official logos go on over the paint. Everything is sealed in a clear coating that protects the stick and adds a tacky texture to the shaft, giving the player a better grip. A plug tops off the open end of the hollow shaft. And just 2 hours after the process started, these sticks are ready for the puck to drop.